Hello and welcome to the last exercise on chapter 6. I decided to do it today because I want to finish this chapter, and focus on other things that I have pending. I have my, tasks over here. And uh, yeah, this problem inaugurates uh, what I think will be better to do on Sundays because it the next problems, as I remember, will require at least for me like 3 hours, 5 hours. So I'm not sure about doing this on weekdays because I need to come up with perhaps some products. I don't know, some video games, some entertainment in Blender. I don't know. And this is like this functional programming is cool stuff, it's good stuff, but it's more suitable for the yeah, to do it on Sundays, at least in my case. I don't know. So that's the reason I wanted to pack everything, lots of Scala content that you have seen in this channel lately, because I want to finish this and then starting with chapter 7, do it on Sunday, starting on August, most likely. Scala is object oriented. This is a cool thing, good thing to have in mind. It's by Martin Odersky. This book, Programming in Scala. Yeah, we have the code from the last exercise. Let's see if we can solve this because it's marked as a hard one. This code is on the video description. So let's get started. Let's put some time limit because I don't want to spend, like yesterday, 2 hours and a half. I don't want to do that today. I want to play the guitar. That's why I was thinking just finishing this thing being by solving it or by taking a look at the answer. The upcoming problems, you know, for me it's better, like on Sunday, which perhaps I'm thinking it is sort of magical day in which I have time. I don't know. Yeah. Besides, look at these 4 minutes. Time flies. I can't believe. I can't believe it. So let's read the problem in its entirety. Exercise 6.11. It is not critical, so we are good on that side. The ones marked with this black square are critical, and you should really try hard to solve them. And the ones with without the black square aren't critical and they don't affect, according to the author, your learning experience. Besides, this is a hard one, so we can safely take a look at the answer if we are like struggling a lot. Let's see if we can have an idea in the 20 minutes ahead. It will be quite obvious if we are really lost in this problem, or at least we have glimpses on how to solve it. So exercise 6.11, hard to get some experience using state, implement a finite state automaton that models just this thing. Scares me. That models a simple candy, but I like candy. Okay, that models a simple candy dispenser. The machine has two types of input. Okay, let's read again this thing. That models a simple candy dispenser. I will like to draw this. I haven't seen a candy dispenser in, I don't know, never? Well, let's imagine a toy dispenser, which I have seen in some, how do you say, fair? So, yeah, candy dispenser. This, this machine. I suppose there is a glass over here. And there is this candy dispensers called, some chocolate, some, how do you call these? I pallets? How do you say this in English? Some candies. Yeah, more ice cream. Yeah, look at this, another beautiful candy. Yes, this is like, I don't know. While drawing that was alleviating. The machine has two types of input. You can insert a coin. Let's change color because money golden. This is a coin. There. Or you can turn the knob to dispense candy. Apparently there is a knob. I don't know what's that. Perhaps like some kind of this thing that rotates. Okay. It can be in one of two states, locked or unlocked. Which one? The candy machine or the knob? That's the ambiguous nature of language. So I will assign that value to some kind of thing over here that says lock, unlock. It also tracks how many candies are left and how many coins it contains. So it's quite an advanced machine, you know. Uh, it does a lot of things already. So you have to things over here. Coins counter. Candies counter. I should practice with a counter first. Now that I'm seeing this counter, I should practice with a counter state prior to this live session. So I arrive more prepared for this. But now we are here. Okay, so the thing, that's all. And then we have some code, and the rules of the machine are as follows. Inserting a coin into a locked machine will cause it to unlock if there's any candy left. Turning the knob on an unlocked machine will cause it to dispense candy and become locked. Okay, what else? Turning the knob on a locked machine or inserting a coin into an unlocked machine does nothing. A machine that's out of candy ignores all inputs. The simulate machine method should operate the machine based on the list of inputs. What's this? And return the number of coins and candies left in the machine at the end. For example, if the input machine has 10 coins and 5 candies and a total of 4 candies are successfully bought, the output should be 14-1. Well, let's see. 30 minutes, and we already have people in here. One views, 30, 23 seconds, which is great. Oh, we have consumed 10 minutes of the 20 that we have allocated for understanding the problem. I don't want to, I can do this, but I don't want to spend 6 hours. So let's get started with the code they gave us. Look at how beautiful is this. I'm going to use this this worksheet over here because type run is another thing. It's from the previous. Okay, we need to use, let's move this down below to, because these are related to the run context. Let's see if this works. Yeah, we got rid of the print action one RNG. Yeah, I can't believe it. Let's start with this. Let's make some excuses. Let's make some excuses too. I haven't written any big project with Scala. Also, this is like we're doing this. I only like programming. I don't spend time writing big projects, which I'm going to change starting tomorrow because I have done projects in the past 10 years ago on my own by myself, uh, delivering the product, charging money, freelance. But eventually I became only a book reader and having jobs. But now I want to return to writing projects because look at this, what this guy says. This is off topic, but it's very important because at the end of the day, these theories are most likely for me to my own benefit, to learn something about me. Okay, this is Peter Norvig, you know the guy, book, reading, reading, oh my god, book, the book, repeating, so the book, okay, you won't have time to learn much. So the book can only be talking about a superficial familiarity, not deep understanding, as Alexander Pope they said. Little learning is a dangerous thing, which is I don't know anything in depth. Where is okay? It was book learning. I was looking for book reading. So this is the phrase I was looking for. In any, this is Peter Norvig, right? The guy at if I remember, this guy did the translate by Google. At least he was explaining how this translate algorithm works. This guy is a master of programming. And I read this like years ago, and I can't believe how I didn't apply it. I am not regretting anything. I'm not complaining. I like the way I have lived. I would change some little things, just little things. But uh, look at this. In any case, book learning alone won't be enough. I, for me, it's an urgent matter to stop just reading and reading and reading and reading, consuming information from several books that I don't finish. It's crazy, it's nonsense, it's terrible. As Steve Jobs said, it's terrible. Yeah. In any case, book learning alone won't be enough. Computer science education cannot make anybody an expert programmer anymore. Look at this. Look at this. Computer science education cannot make anybody an expert programmer any more than studying brushes and pigment can make somebody an expert painter. And here he's quoting this guy that I don't know who it is. I'm sticking with this, which is by Peter Novick, some guy that I admire. But it seems the guy is big time too. One of the best programmers I ever had, and only a high school degree. But I don't know. Perhaps this guy was a great mathematician. I don't know. What this is a link to Mozilla, right? I have this. Okay. So yeah, it's all about practicing. There is a book by Bjarne Stroustrup. Another book. I don't remember. Principles and practice using C++. I don't remember if this is the book. Most likely it is. The practice of programming. Yeah, it's still I'm stopped reading books. That's for sure. No more books for me. I just it's nonsense. I will continue to read books on mathematics because it's a different thing. But on programming, I just no more concepts for me. I will try to build something. But instead, you need to read documentation and some manuals. There will be reading. There will be looking for information. I hope these videos help somebody looking for answers. It is the probability of that happening is almost zero because who will be seeing 22 minutes of a guy pretending to solve an exercise and starts talking about some advices for life and education. That's silly. Well, that's the information. The answers are buried in the sea, in the ocean of information. There lies the treasures. Okay, let's continue. Any input? It's going turn. I don't know what this guy is pretending, but okay. Case class machine locked boolean candies going and that's all she wrote. She said in a letter. Now let's copy and paste this thing, which I think it's unrelated, but such is life. Unrelated to this. Let's comment this code. Let's run this code. Okay, it compiles. So we have a num input coin turn. We have a machine block boolean can receive coins. Okay. And then we have this simulate machine inputs, which is a list of input. That means simulate machine inputs list input 100%. I will disconnect power. I need to do that, but I'm like that. 25 minutes. Inputs is a list of inputs. So input, I'll input. Okay, it will take this label. Let us see. I'm going to draw this thing. So inputs is a list that will contains coin, coin, turn, for example, or it can be empty, right? Simulate machine takes a list of inputs and it gives you a state machine with an int of coins and candies. Um, it seems easy, but I don't know. The simulate machine method operates the machine based on the list of inputs and return the number of coins and candies left in the machine at the end. Let's, let's decipher this. What's this? Can you believe it closed? Yeah, we messed the thing, the drawing. We have this. And what's this? What's this? What's this? State machine. We have a tape run, which is a state from RNG to A. So I think So our little fellow in here is a machine. I think Macintosh comes on here. Machine. So this is our state machine in int. In reality, is this function. This is the state we are trying to model. And now, what can we do with this information? I think it will be like 2 hours. Now, what? Now, what we need to do? To get some experience using a state, implement a finite state element that models a simple candy dispenser. The machine has two types of input. You can insert a coin or you can turn the knob to dispense candy. It can be in one of the two states, locked or unlocked. It also tracks how many candies are left and how many coins it contains. The rules of the machine are false. I don't know what to do. Let's think for 12 minutes. The rules of the machine are as follows. Inserting a coin into a locked machine will cause it to unlocked if there's any candy left. I was thinking this case class machine will have methods in here, but most likely the machinery, the mechanics, the rules, these 1, 2, 3, 4 should be encoded in def simulate machine. Let's try that. Let's do a pattern matching to process the inputs. We need to return state of the machine. I don't understand. If the input machine has 10 coins and 5 candies, where is the input machine? There is no input machine here. Let's build one. Well, my machine, my machine. Machine, my machine. If the input machine has 10 coins and 5 candies, a total of 4 candies are successfully boxed, the output should be 14. Log true, yeah. He says that it has 5 candies. Yes. I'm not sure if I am doing this the right way. Seems like I didn't like this thing. Because the type signature it doesn't have the entering machine, so it should be in the companion object or in here. Are you able to see me? Yes. How can I return a state? How can I build a state? I'm quite slow. States unit. Some state and the state machine, just to know, to get things going. State machine equals a unit of 99, and then we return the state machine. Let's run this, and at least we have all of this right. Simulate machine. It's not number of regular machine. It is. Here we have. Yes. We need earnest. Oh my god, it's getting late. How can I bring this thing? Does that works? Machine, select machine. Machine. I think I'm confused. Let's put this thing. How do we do it here? Object state. What's this? Let's get rid of this. Let's. I'm not sure about this. I'm doing here. Perhaps we need to take a look at the case classes. Okay. So the thing needs to be here, but now I am doubtful about these things are like immutable. I'm very lost. What I'm doing, I'm lost. Now we are making progress, but we have a problem here in the sense that we are getting 9, 9, which we are saying that in here, and we're getting the machine we are entering. These numbers should be the same. This will be the result. I think we are right. This is how it is modeled. This is the way we have modeled. Uh, where is it? The state here. Wow, the entire hour just analyzing the problem and having this. I think it will take us 3 hours, but the good thing is today I'm not going to exercise while I'm not taking any walk, so I can afford to be here. And I decided to devote this day to Scala to finish this chapter. There is an upcoming video on checking the answers for the exercise, comparing, or maybe not, I'm not sure. And then forget about this thing and only doing it on Sundays. My guitar. Okay, now we have a problem here. This is okay, but now I am being lost in here. Kind of lost in here. You are kind of lost in here. We need access to this parameter. For example, let's suppose I want, for the case of Neil, let's suppose I want to return the machine by itself. So we are, like in here, we are returning a state of SB, and we don't have any state constructor, any apply over here. We are just returning the function expression. So I will try to do that. This is a machine. Start. Oh, I'm not pressing. Okay, let's try this. So it's not quite right. This is the state. Oh my god, this is like, I don't know. Okay, we after 1 hour, uh, we uh, we managed to make a little baby step. Uh, so yeah, so in order to avoid too much, writing lots of characters, I will call this N. Wow. Yeah. Case tail. Well, perhaps next was okay. Now we can start worrying about, well, the rules. I think this is the answer. This is the expected answer for a nil list of inputs, for an empty list of inputs. I mean, we are applying to some machine, the simulate machine. Yeah, this is it. More views. There are lots of rules in here, and this one seems like a shortcut that we should take care early. I mean, I'm starting to think that it is hard in the sense that there is lots of conditions to take care of and not the level of abstraction that you have to achieve to solve the problem because we are getting there with this little fellow over here. But now look at this. We will have, we will be checking if the input is a coin or or if it's a turn, and then if it is a coin, more conditions if there are candies, or if the machine is locked or unlocked. So that's the problem. I didn't move my guitar. It's getting some light. Yeah, we put it over. I don't know what to put my guitar. Yeah, let's continue. Look at this. More. Let's start with this. A machine that's out of candy ignores all inputs. A machine that is out of candies ignores all inputs. I will use if perhaps it's more adequate in Scala to use case. I don't just trying to finish this and forget about this thing and only do it on Sunday. I am unemployed right now for like this is like thousand times I tell you this. I'm sorry. Perhaps it has become an excuse to be unemployed, to actually not engage in anything and not finishing any project. But I'm learning more and more about myself. Yeah, let's use it. If m with candies equals 0, then we will return this thing. Else, now we are here. I'm giving you an example of a level of abstraction with algebra. I don't know modern algebra, abstract algebra, but I think it requires you a certain capacity to see bigger structures. Like if those structures are machines, then your brain needs to be able to operate on those bigger machines. Your brain needs to be even a bigger machine than those structures. I don't know. Think like a big robot moving big machinery, you know, taking taking pieces, big time pieces, and transforming it. I I think that's related to the level of abstraction, more complexity. And if m can is equal 0, then yeah, let's check that and build a machine without uh, without candies. Okay, we were able to access the candies to compare it if it is zero candies, sorry, and then ignore everything. We are passing, well, we are passing a nil list, but since we have tested this part, it is time for us to build a list of inputs. We have tested we have tested the nil list with this. Remember, now we have tested the zero candies, this part of the code. Don't do this, please. If you are on a team, just engage in a more systematic testing approach so you can be assisted by programs to see if you have coverage of this part. It is time for us to build a list. Let's coin, only coin. So now we shall get an error because we have candies. We have five. Okay. If this book were written by a machine, I certainly won't be exercising this thing. I won't let a machine. Well, I need the money, so yeah. If a robot gives me unemployment, yes, I will accept it. But I don't know. I don't know. People in the future, I don't know. Information will be synthesized by robots. And we will have to. The one controlling artificial intelligence will rule the world. That's for sure. And all of us peasants will be submitted to that insane amount of computational power. That's what I think. Yeah, we shall get like this is section that these things Python. Okay, okay. I can't believe it. Now we need the error. We don't have a nil. I think this should fail because we are passing in. Uh, we are passing. What needs to be done here? Input, input, turn, turn. There should be an exception here because we don't have the case for. Yes, it should fail. We are trying for this thing to fail, but we are not getting any failure. Going, going. Perhaps is this worksheet is helping us, or Scasti is helping us, because if we were over here, I have seen these errors on not exhaustive. Oh my God. Unbelievable. Oh, okay. Now, I was trying to exemplify this thing. I read about this on Apply just some 2 hours ago. Can we use, what can we do here? Int. Perhaps it will be the same. Name in lunch case, and I don't remember the what's 0. Okay, you know, this is the error. But we are unable to see it. It failed, when it was 9, because there are no cases. What I think Scasti is helping us in here. I was expecting for this to fail, but this is cool too. Even better. It's getting dark over here. 1 hour and a half. I talk a lot and do a little. Starting tomorrow, no more talk. I already said what I wanted to say. There was this guy, Grigory Pellman, that according to some documentary I saw, like, I don't know, years ago, uh, he was saying something like, I already said everything I wanted to say, so I am not Grigory Perelman. I am not in that level of mathematics. What I have become tired of talking even to the camera. I have nothing else to say, I suppose. I don't know. So I would like to play some music, but I don't have the licenses to play it now. Okay, Hit next. I think we can call it a day because we got what this exercise was about. Uh, I mean, the elements of the program. Now it's all about checking for conditions and, uh, getting the rules right in here, encoding the rules. You know, but the main uh, part was to, return this thing, coin, coin. Let's be here for about let's spend the 2 hours because this is my goodbye to Scala. I'm kidding. I will continue to do Scala on Sundays. Uh, and yeah, I will never, because somehow I like this programming language. I don't know why, since it was a lot at the first love at first sight. I remember, I remember hearing about this programming language years ago, and I wanted to learn about it, but all people were talking about functional programming, but you can do object-oriented programming in Scala. I will make videos about this, even if some people gets angry. Like Scala is functional. You don't be side effects. I don't know. Most likely, it will be making some videos about this part of the Scala, so more people get into this language and like enjoy it. And then if they like move to the functional, I don't know. Perhaps I will end doing nothing most likely. So we have covered this 10 gap, turning the knob, turning the knob on a lock machine. This is a cool one too. Or inserting a coin into an unlocked machine does nothing. Hmm, it's not that straightforward. Yeah, let's be to 2 hours and then yeah, we'll no. Let's actually be here the 2 hours, but some of the 2 hours will be devoted to check the answers for all the exercises, including this one, and we will close in this chapter 6. I'm very happy because I was thinking that I would be able to even start, but as you could see, I was able to draw the machine and come up with this little thing. I'm very happy. I am, as the guy in Westworld says, I am an underachiever. Okay, so yeah, okay. Now we can operate the thing because now we have access to head that we will call input. And next, let's do this in Scala repo. Are you able to see me? It's getting dark in here. Scala. Well, let's write the input case going down. Um, while input equal input of type input equals let's import input of type input. Scala can insert this, so I don't care. Going. Let's match input match before case going. Hello, case turn. Cool. Okay, we can do pattern matching on enums. So input match exhaustive. Thanks, disgusting. Look at this. Beautiful, beautiful. Okay, case going. Lots of conditions. And yeah, let's put an alarm because I want to let's do this for about 20 minutes. No, 15 minutes. So we can take a look at the answers. And then I will be singing because yeah, 14, 20, 15 minutes. Yeah, 6, 6:20. And then only 10 minutes to check the answers. Okay. Okay. Inserting a coin into a lock machine will cause it to unlock if there any candy left. Okay. Inserting a coin into a lock machine will cause it to unlock if there any candy left. Perhaps we can, put some intermediate values over here. Candies equals and candies. And if candies equals 0, okay. Well, I think this is redundant. Why? Because if we are in here, in this part, there are candies. Because otherwise, we will, uh, like returning this machine, this state. I'm trying to think that, but yeah, I will assume that. Okay, and you will experiment that in here. Yes. Well, let's put the condition. If m can this greater than zero, then but oh no. Where is this copy method? Sorry for this. Come on, case class. My God, case class, a rectangle, length, int height, int bar rect equals rectangle 950, 50 rect that copy height equals 99. Oh no, 100. Okay, it gives me a new rectangle with this new. We call this to unlock if there is no. Okay, else. Again, this thing. I think we are doing this all wrong because we are not recursing anywhere. But let's continue. Yeah, we will take a look at the answer because in here it's all about the conditions. Turning the knob on an unlocked machine will cause it to dispense a candy and become locked. Turning the knob on an unlocked machine if n unlock. God. Let's see if this compiles. I think I'm going to turn on the lights. Oh, are you able to see me? It's very dark. I'm going to turn on the lights. We're back. Hopefully you're seeing a little bit better. Okay, now what? For example, if the input machine has 10 coins and 5 candies, and a total of 4 candies are successfully bought, the output should be 14, 1. How can we model this thing? Inserting a coin into a lock machine will cause it to unlock it will cause it to unlock if there is any candy left. Okay, so it will be coin, it will be turn, it will be coin, it will be turn, it will be coin. Oh my god, coin, 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 coin. I suppose this is the series of steps. Now in here, nothing will happen because we are not recursing on this thing. You see, we are still with 5 candies and 10 coins. So this is a lot. No, 47. We should be taking a look at the answers right now. But yeah, let's list coin. Okay, we have, where is it? Okay, 5 candies and 10 coins. If we are able to move to perform these two operations, we shall end with 4 candies and 11 coins. So nothing's happening even when we have these two. Why? We shall see. Because we are not recording for starters. So else input match case nil. We're returning this thing. I think we will have some sort of accumulator somewhere. Let's start with coin and then forget and then build upon that. So at this point we should be over here. We should we should be seeing this thing. But I don't know because we are on this mode. Okay, it was cool. Look at this. We should be seeing this print. So we went here. Look at this. There's something wrong in here because we entered a coin. Okay, we have We have this thing, a machine with 11 coins in the state, you know. Now we shall see. Well, let's quote Gandalf. You shall not pass. And indeed, if we are correct, this thing it shouldn't be printed because printed. Yeah, it shouldn't be printed because because we are not recursing. We are not calling again simulate machine with the tail of the inputs. So we shall not see this. You see, we are finishing over here. So we need to recurse with the tail of the input. And to do that, let's recurse by calling simulate machine. And simulate machine expects what does it expect? The next or the tail of the input, which is here. I'm not sure if we should be using this map or flat map. I totally forgot about these functions. They should be, we should be using this, especially here, I suppose. And we are applying this, and we will be in problems here. Well, simulate machine returns a state machine. Let's see. You see? Almost 2 hours. Yeah, because we are returning this, the result. Let's get rid of this. And we have this thing. Yeah, so we can call it a day because you are exercise for the reader. Because now you are just You just need to propagate this behavior, when it is required over here. So yeah, uh, since we have spent 2 hours, and I want to see the answers to close this chapter 6. And if you want to, you can spend more time continuing in this, propagating this behavior, and perhaps figuring out how to use plot map map 2 probably in this context. But for me, it's okay because I want to, and yesterday I didn't play the guitar and not even study mathematics. So uh, the main thing about this is that I was very afraid that I won't be able to, to even model the thing. But it wasn't hard in terms of abstraction, but it is like a lots of conditions. So you can take it from here. And mm, what? Uh, 2 hours? Yeah, let's take a look at the answers. Please, you can stop the video right now. I'm not sure who, but in the future, if someone is taking a look to this right now, please stop the video if you want to continue with this. And because I am about to see the answers, um, conclusion, and how do you say this? Clausering? Because I am clausering the chapter 6, very happy. And in this chapter, we touched on writing purely functional programs that have states. We used random number generation as a motivating example, but the overall pattern comes up in many different domains. The idea is simple: use a pure function that accepts a state as its argument, and it will return the new state alongside its results. Next time you encounter an imperative API that relies on side effects, see if you can provide a purely functional version of it, and then use some of the functions we wrote here to make working it more convenient. More convenient. A summary: the Scala of the random type provides generation. Okay, so the random number generation can be modeled as a pure function from math making use stateful API is pure by having the API compute the next state of the current state. When the functional approach feels awkward tedious, look for common patterns that can be factored out. A rand A type is an alias for a function. There are a variety of functions that create and transform rand values like unit map. Opaque types behave like type aliases in their defining scope, but like related types outside their defining scope, allowing the definition of new types without runtime overhead. Extension methods can be used to add methods to opaque types. Case classes can be used to opaque. All right. State supports the same operations as RAM. Probably for the inputs, we should use sequence. I mean, you can spend like entire days with this learning and getting deep knowledge, as Mr. Peter Norvig says. Even with this book, it helps you with this little problem to gain a deeper understanding of several Scala constructs. And it's all about the time you put into the practice of any given skill. I tell myself I don't have time even when I am unemployed. I don't know if that's a defense mechanism or excuse to not engage or compromise or commit to any simple thing. The state data type simplifies working with stateful APIs by removing the need to manually thread into. The state computations can be built with for comprehensions, which result in interactive looking code. Okay, and these are the answers we have seen these, you know, in a previous video, if you remember. This is the ins. Oh, this is the tail recursive version. This is a good one. Yeah. Let's take a look at this. Go counting. This is accumulator. No. This counts less than or equals to 0. The accumulator and the R. Let's suppose they give 5. Else, but x int. But lista de Spanish. 99. So yeah, this is reversed. This will be, you know, this will be in reverse order too. Perhaps using a pen over here. Okay, perhaps using a pen. You see, we have this, and it is like the same as theirs. Go count pending else next in Yeah, as you saw, this goes in reverse order. But now, using a pen, we could have a chance to, you know, to have the list in order. Okay, it's in here. Note that the list of numbers output by this implementation is in the reverse order as the numbers by the original, not the recursive implementation. If we want to address that, we could reverse the output list in the main body of hints. Yes, but it's not quite as straightforward as you saw. But yes, you can do that. But this author knows a lot. He's an expert. Like he explained very detailed. This book is great. If you can uh, beat the mindset of not having time. Okay, this is we've seen this up to sequence using whole right. Look at this unit is annotated. Now in here again, ints, I don't know. This field is just, let's suppose you pass what's int. No negative int 2 hours and 10 minutes. This is from yesterday. Now, look at this how clean this is instead of and you see they are using sequence. I was thinking on sequence. I totally forget about get and run. They have traverse. This is just stuff if you want to spend more time. It's like a lot of skills, right? This is a good example to study carefully, which I will do next Sunday. Look at this. You can even uh, pick or take a look inside the values. I mean, match on the specific values. Look at this. Yeah, this is a good one to study carefully. Yeah, I forgot about this. I forgot about this. What is get? I didn't even put it over here. And this was present in the code. Well, it doesn't matter right now. Or only on an input. Yeah. Oh, this is great. But where is modify? We don't have any modify method. Where is modify? But yeah, you can, like study this carefully. I certainly will do it even, and also taking a look at the official repository to the hints, and the answers, because this is a good topic, which is a preparation for the next one on functional modeling. I don't know, but yeah, that's it. 2 hours and 16 minutes. Let's let's say goodbye for 30 seconds. Yeah, we have the time over here too. So yeah, thank you very much. I don't know if you made it to the end of this video, if you are watching it in the future. Thank you very much. Bye.